Welcome to Vidhyalakshmi YouTube channel. Today's section I am explaining the valence bond theory from coordination chemistry. So before going that example, we know the valence bond theory tricks. So I will give some tips for you. Tip number 1. So you first identify the oxidation number of central metal atom. So what is the tip number 1, student? Oxidation number of central metal atom. This is tip number 1. Then tip number 2, you know the transition element electronic configuration. So you know the electronic configuration of transition metal. Transition metal series: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So atomic number of scandium is 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, cobalt 29 and zinc is 30. So actual electronic configuration of transition metal: scandium, argon, 3d1. What is the atomic number, students? 21. That's why 3d1, 4s2. Then move to titanium. Titanium electronic configuration: argon. So 22 means 3d2, 4s2. Vanadium, argon, 3d3, 4s2. And then chromium electronic configuration: argon, 3d4, 4s2 we are expecting, right? The same manner means we are expecting 3d4, 4s2, but the actual chromium electronic configuration is 3d5, 4s2, sorry 4s1, because extra stability for off-filled electronic configuration. That's why one electron shift from 4s to 3d. So actual electronic configuration: chromium 3d5, 4s1. Then move to manganese. Manganese the same manner, electronic configuration: argon 3d5, 4s2 and so on. Then iron electronic configuration: argon 3d6, 4s2. Cobalt, argon 3d7, 4s2. Nickel, argon 3d8, 4s2. Then cobalt we are expecting 3d9, 4s2, but actual electronic configuration of cobalt is 3d10 because of fulfilled electronic configuration 10. So argon 3d10, 4s1. This is, and this one very important, students. Sorry, this is copper. Then zinc electronic configuration: argon 3d10, 4s2. So only the variation of chromium and copper. Chromium exhibit 3d5, 4s1 electronic configuration and copper exhibit 3d10, 4s1 electronic configuration. So tip number 1 already you know that oxidation number of central metal atom. Tip number 2, electronic configuration of transition metal. Then move to tip number 3. Right. Tip number 3 means identify the types of ligand. Identify the types of ligand. Right. Whether it is strong field ligand or weak field ligand, you should identify. So weak field ligand, strong field ligand. According to valence bond theory, weak field ligand cannot pair up the electrons. This is very, very important, students. Weak field ligand cannot pair up the electron. Then what happens? Strong field ligand can pair up the electron. Can pair up electrons. So you don't know what is weak field ligand, what is strong field ligand. I give tips for you according to spectrochemical series: fluorine, chlorine. Such a cases are called weak field ligand. And then ammonia, NH3 is ammonia, CN is a cyanide, is called a strong field ligand. So Tip number 3, identify the types of ligand, whether it is weak field ligand or strong field ligand. What is the nature of weak field ligand means? Cannot pair up the electron. Strong field ligand means can pair up the electron. Example for weak field ligand, fluorine and chlorine. Example for strong field ligand, ammonia and cyanide. Then move to tip number 4. So you should know the coordination number, hybridization and geometry of the complex. So coordination number 2 means geometry. Then hybridization, you know. Right. Coordination number 2, hybridization. Hybridization. One s orbital, one p orbital. Geometry, linear geometry. This molecule look like this. Linear molecule. Right. Then move to coordination number 3. Coordination number 3, hybridization. sp2 hybridization. It means one s orbital, two p orbital. Geometry, trigonal, planar, like this. This is called a trigonal planar. Then coordination number 4. Coordination number 4 will approach two types. One is dsp2. It means 1 d orbital, 1 s orbital, 2 p orbital. Coordination number 4. So square planar complex. This complex will expect square planar. Like this. This is called a square planar complex. Then coordination number 4, sp3 also present. This complex exhibit geometry tetrahedral in nature. Then move to coordination number 5. Coordination number 5, hybridization, dsp3, dsp3 geometry, trigonal bipyramidal. Trigonal bipyramidal in nature. Like this. This is one pyramid, this is one pyramid, like this. Trigonal bipyramidal. Trigonal bipyramidal. Right. Next, coordination number 6. Coordination number 6 also exhibit two type of hybridization. One is sp3d2, another one is d2sp3. This is also coordination number 6, this is also coordination number 6. You can calculate 1s orbital, 3p orbital, 2d orbital. The same manner, so here d2sp3, 2d orbital, 1s orbital, 3p orbital. This is also exhibit, both are in coordination number 6, both are exhibit octahedral in nature. Right. This is tricks for valence bond theory. Now move to question. Question number 1. Compulsory. We are expecting valence bond theory. Based on valence bond theory, one question will come in public exam. Question number 1. CO F6 3 minus. So what is the tip number 1? Find the oxidation number of central metal atom. Right. So what is the central metal here? Cobalt. What is the ligand? Fluorine. So identify the oxidation number of central metal atom. So cobalt is considered as X. It is a central metal atom. So you put plus. Then how many ligands are there? Fluorine. 6 ligands are there. So you put 6. Fluorine oxidation state usually -1 oxidation state. That's why you put -1 oxidation state, which is equal to what is the formal charge? 3 minus formal charge. That's why you put here -3. Okay. Then solve this equation. X 6 ones are -6, which is equal to -3. -6 go to that side, +6 +6 -3. So equalize. So X equal to. So we get the answer +3 is a oxidation number of cobalt. Right. Then next, electronic configuration of cobalt. Electronic configuration. You know that electronic configuration. Already I told cobalt atomic number 27. So cobalt atomic number 27. Actual electronic configuration 3d7 4s2. This is electronic configuration of cobalt. Argon 3d7 4s2. Actually, what is the oxidation number of cobalt? Plus 3. So, remove the 3 electron from the valence shell electronic configuration. 2 electron remove from s orbital, 1 electron remove from d orbital. So, we get the answer argon 3d6 4s0. 4s present but no electron will be there. 4p also present, no electron is there. 4d also present, no electron will be there. So, you can put 0 0 like this, right. So, then draw the actual electronic configuration orbital level. So, d orbital means you can write 5 orbital because s orbital 1 degenerate are possible, p orbital 3 degenerate, d orbital 5 degenerate, f orbital 7 degenerate. That's why d orbital I put 5 degenerate 5 orbital. S orbital 1 degenerate, so only 1 orbital. P orbital 3 generate. I mean 3 degenerate are possible. That's why I put 3 orbital here. Like so, then fill up the electron 3d6. It means 3 electrons are there. You can put the electron is according to Wound's rule. Electron unpairedly fill, then paired. That's why the actual electronic configuration look like this. Then approach the ligand. Types of ligand, you know that it is a weak field ligand. Already I told. That's why cannot pair up the electron. So actual electronic configuration manner is continue. Then ligand approach the metal. Each ligand donate a pair of electron to the central metal atom. What is the students? Each ligand donate a pair of electron to the central metal atom. So how many ligands are there? Totally 6 ligands are there. 6 ligands mean 6 d orbitals are there. We record. It means ligands record. So suppose 1 s orbital, 3 p orbital, d orbital is also present, but no electron will be there. I already told. So suppose we record 1 s orbital, 3 p orbital, 2 d orbital. That's why hybridization sp3d2, right. So actual hybridization is sp3d2. sp3d2 is hybridization. Hybridization is sp3d2. sp3d2 mean geometry, octahedral in nature. Okay, then magnetic properties, whether it is diamagnetic or paramagnetic. So you see here 1, 2, 3, 4. 4 unpaired electrons are present. Unpaired electron presence mean magnetic nature is paramagnetic in nature. That's why magnetic properties paramagnetic in nature. So what about paired electron? Diamagnetic in nature, right. Then spin only momentum. Spin root of n into n plus 2 is a formula. N means number of unpaired electron. So you know how many number of electron are present? 1, 2, 3, 4 unpaired electron. Only calculate unpaired electron. 4 unpaired electron are present. That's why 4 plus 2. 4 plus 2, 6. 6 4 so 24. Root 24. Root 24 value 4.89 or round up the value 4.90 Bohr magneton. In this complex, spin only momentum value 4.90 Bohr magneton value. Then types of ligand, whether it is whether it is types of complex, outer orbital complex or inner orbital complex. You see, this is a outer orbital complex because ligand approach only the d orbital. See, each ligand donate a pair of electron. That's why here occupy 2 electron for ligands. So D2, 4d orbital are involved in the hybridization. That's why this complex is known as outer orbital complex. Then spin value, this is a high spin value because of unpaired electron present. Minimum 1 unpaired electron present means its a spin value is maximum. Here 4 unpaired electrons are present. It is a highly spin molecule.